Hi, I'm Nitya, your tutor at Nityaz Academy. Let's learn thermochemistry together, step by step. Every reaction is also an energy story. Breaking the bonds in reactants always takes energy in. Forming the new bonds in products always gives energy out. Whether a reaction warms or cools its surroundings depends on which step wins. That net difference between energy absorbed and released is the heat of the reaction. Bonds store the energy. Reactions split into two camps. Exothermic reactions release more energy than they absorb, so they heat their surroundings, like a burning candle. Endothermic reactions absorb more than they release, so they cool their surroundings, like an instant cold pack. Touch the container, and you can often feel which is happening. Energy is always flowing somewhere. Burning methane is strongly exothermic. The bonds that form in carbon dioxide and water are very stable and low in energy. So far, more energy is released forming them than was used breaking the fuel apart. That leftover energy pours out as the heat and light of a flame. This is the energy that cooks our food. Now an endothermic example, an instant cold pack. Inside, a salt like ammonium nitrate dissolves in water, a process that absorbs heat. The energy needed to pull the particles apart is drawn from the surroundings, so the pack and your skin feel cold. No ice required, just a clever endothermic reaction working in your favor. Here is the takeaway. Reactions absorb energy to break bonds and release energy to form them. If forming wins, the reaction is exothermic and warms its surroundings. If breaking dominates, it is endothermic and cools them. From engines to cold packs, thermochemistry explains why chemistry can either heat us up or chill us down. Great work! Keep practicing with Nitya at nityazacademy.com for free lessons, worked examples, and practice.